when few alkanols are presented to you, how will you identify that this particular one is a secondary alkanol? We have been able to differentiate or to know how primary alkanols look like, or how you can easily identify them. And today we are looking into secondary alkanols. And the simple general formula for you to identify secondary alkanols is R2CHOH. And the two things you are going to hold on here, two important facts or points here are, first is the number of the alkyl or phenyl group, because I've told you that R does not represent only alkyl group. R also represent phenyl group. I'll show you the examples in tertiary alkanols where we have phenyl, methanol, where we have triphenyl methanol. Yes. Now, in this case, we have R2CHOH. The R I told you represent, R here represent either the alkyl group or phenyl group. And you will agree with me here, if you look closely, that the OH is attached to CH. While in the primary alkanols, the OH is attached to CH2. If you are very careful or observant. Okay, so I have few examples. If such is the case, if you have known this little preamble, I want to give us few examples of secondary alkanols. I have 3 here. I have more than 3, but because of time, I will give only 3. Okay, I have the first one I have here is propen-2-oil. I have is propen-2-oil. And the question is, why is propen-2-oil a secondary alkanol? Let's see why propen-2-oil is a secondary alkanol. Look at this formula, CH3, we have the CHOH, and we have the CH3. This is what we have here. So, the facts, or what we are considering here, is the number of the alkyl group and the carbon hydrogen atoms holding the OH. So here we have 2 alkyl groups. We have R1 and we have R2, and we see that the OH is attached to CH. I hope you will agree with me. It's just a simple identification. If you know this formula, you'll be able to identify them at a platter of gold. So this is propen-2-oil because it has 2 alkyl groups and the OH is attached to H atoms. Okay, so the second one I have is butane-2-oil. Butane-2-oil. And why is butane-2-oil a secondary alkanol? We will see. So we have CH3, CHOH, because I'm talking about 2. That's why I'm strategically positioning my OH. 1, 2, 3, and we have CH3. So here, you will agree with me, we have 1 alkyl group, 2 alkyl group, and the OH is attached to CH carbon or CH atoms. So in this case, this is our R1, this is our R2. So if I want to name this, I am naming from here to give priority to the functional group. 1, 2, 3, 4. So it is butane-2-oil. So this is a typical example of secondary alkanol. Last but not the least, what I have today as one of the examples of butanol, or examples of secondary alkanols. So I have pent-2-oil is also a typical example of secondary, alkanols. So we have CH3 because of the position of the OH. I have it here. CH2, CH2, and CH3. Am I right? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, it is correct. So you will agree with me, we have one alkyl group, two alkyl group, and the OH is attached to carbon hydrogen atoms. Okay, that is CH atoms. So if I am naming, I'm naming from here to give priority to OH, because if I name from here, I will give OH a higher number. So that is not what the rule is saying. So I have 1, 2, 3, 4, and 5, which is pentane. Then 2 or is a typical secondary alkanol. And 3-hexanol is also a typical example of secondary alkanols. I hope I have simplified it enough. Okay, so I want to see you in my next class. Bye bye.